Hello friends, in this video I'd like to solve the following problem from the Swedish Mathematical Competition, final round 1990, problem number 1. Let d1, d2, and so on up to dl, let's say, be the positive divisors of n, which is 1990 factorial. Prove that the sum which goes from k equals 1 to l of dk over square root of n equals the sum which goes from k equals 1 to l of square root of n over dk. My hints for this problem is not very difficult. First of all, think about it. Is it really that important that n happens to be 1990? Because this problem seems to be rather general, and this number seems to be, well, particular, a strange number. And then a crucial observation: justify that function which takes a positive divisor of n and returns n over this positive divisor is bijective. So give this problem a try and I will see you in a minute. Okay, so we wish to prove the following: that sum over all positive divisors of n, d over square root of n, equals sum over all positive divisors of n, square root of n over d. We'll prove it in general without assumption that n is 1990 factorial. Well, this equality is really equivalent to saying that the sum over all these equals the sum over of n over d. Why? Because I have just multiplied both sides by square root of n. Okay. And now, as I suggested, let's consider the following function, which takes a positive divisor of n. By the way, this notation is just for once. D plus of n will mean the set of positive divisors of n. It's not a standard notation, I believe. And returns this number. First of all, it should be pretty clear that this function is well defined. That means this number is really a positive divisor of n. So maybe write it. It really is a positive divisor of n. Because, why? Because n equals d times n over d. And we know that d is a divisor, so this number must be an integer. And moreover, so let's call this function, I don't know, psi. And see the following: psi composed with itself on any d, it's, well, psi of n over d, and it's n over d, which is d. So in other words, the psi is involution, it's identity, which means that psi must be a bijection. Psi must be bijection because psi is inverse of its own. Okay, and now we are pretty close to the solution. So our first sum is this, and because our function is a bijection, we can change the index of summation. So instead of d, let's put that we are summing over n over d, which are divisors of n over d. And well, that means that is exactly the sum over all divisors of n. Why is that? Because this divisibility is equivalent to this divisibility. N over d divides n if and only if d divides n. And that closes our problem. So now we know that our sums are in fact equal. QED, quite easily done. Thank you for watching and I will see you next time. Goodbye.